Now this illustration deals with the system bonding jumper. In accordance with 250.30A1 little a or A1 little b, are you applying the system bonding jumper at the transformer or at the equipment? Now notice it's either or. Notice that transformer is divided at the conduit, and it says you're either grounding at the transformer or the generator, or the service or the equipment panel board. Keep that in mind. Now before we get into this, I'd like to go to note and review the three notes first. Note 1, the system bonding jumper shall remain within the enclosure where it originates. The installation of the system bonding jumper at the transformer is an example of remaining within the enclosure in accordance with 250.30A1A. Note 2 states, the condition of the system bonding jumper could have been made at the first disconnecting means located at the panel board in accordance with 250.30A1B. And then in note 3, the transformer XO is considered neutral point as defined in Article 100 of the NEC. The grounded neutral conductor used as a neutral as well as a grounded conductor for an effective ground fault path, for example, it's defined in Article 100. So those three notes are very helpful as we review the illustration itself. Now, I'd like to start with the transformer. Notice the transformer is fed from the service panel, and the disconnecting means is in the service panel in accordance with 450.14 and the exception. Then notice that the secondary side of that transformer, we have a non-metallic raceway, say, routed to the panel board, and we're going to apply the system bonding jumper there. So again, you say, well, 4-aught conductors coming off of the windings, 4-aught conductors, when I review my table, 250.102C1, I need a number 2 to bond it. You'd say, well, I have 450 kc mil. Now you need a 1-aught there because you have 400 kc mil, and table 250.102C1, I believe, requires a 1-aught. Now, so we're grounding it there. The XO's there, the grounding electrode conductor to the structural steel, everything there based upon 4-aught now would have to be number 2. That would include the system bonding jumper and the grounding electrode conductor to the steel, which would be sized from table 250.66 as required in 250.30A5. Now, let's look at that. We had non-metallic conduits, say, from the secondary side of that transformer all the way to the panel board. Now remember, it's separated now, but they are. Now, if we had that condition, we could ground everything at the service equipment, and the system bonding jumper would still be number 2. The grounding electrode conductor would be number 2 if it connected to the structural steel, which most every case, that's what would happen. But notice the grounded conductor for an effective ground fault path is sized, and you got the sections there. But if it's a neutral, then you'd have to go to 220.61, remember, and it would have to carry the maximum unbalanced load. And if I'm an electrician, as we said, if I see 150 amp neutral load on L1, 140 on L2, 130 on L3, the neutral has to carry the maximum unbalanced load on any phase, so it'd be 150 if I lost the other 2 legs. So that's what they're talking about here. And then, of course, you see the supply side bonding jumper bonding 2 standard lock nuts and a bushing end would also be number 2 also from that table, 250.102C1. But notice, if I did ground at the service, not the service equipment, but the panel board, then notice the XO would have to be removed at the transformer. If that was metal conduit, I would have to have a neutral coming in that would be isolated in that panel board. In other words, I'd have two conductors, one equipment grounded type conductor that would be sized from table 25102C1. Then I could have that neutral just carrying neutral load by 220.61 because it would be isolated from the metal enclosure in accordance with 408.40 exception. So we'd want to kind of keep that in mind. You could apply the exception if you had, say, nonlinear loads, harmonic loads, that kind of thing. Now, I believe that this kind of covers the grounding procedures using a system bonding jumper, either with metal conduit all the way from the transformer to the equipment. If it's metal conduit, you have to bond at the transformer, or you have to pull an isolation neutral and a grounded conductor connected to ground there. So, and I'm talking about to the metal enclosure because you're grounding at the service. So remember what, one other thing, if it's a non-metallic conduit between the transformer and the equipment, you can bond at the equipment as well as at the transformer. You could bond. Wouldn't have to, but you could. So just keep that in mind. You've got to find out first if that's a metal raceway between the transformer and the equipment, or is it non-metallic? Because you cannot have parallel paths when you start reviewing 250.30 in the NEC. So keep that in mind. I believe it's in 250.30A3, I think, right in there in that exception. But you're right in that area. You can't miss it.